दिस इज चैप्टर नंबर 1 कंप्यूटर सिस्टम्स और मैं आपको इस चैप्टर की समरी बताऊंगा जिसमें मेन टॉपिक्स होंगे लॉजिक गेट, एसडीएलसी, नेटवर्क, साइबर सिक्योरिटी। लर्निंग ऑब्जेक्टिव्स एंड व्हाट वी विल कवर। हम इस लेक्चर में क्या क्या चीजें कवर अप करेंगे। After completing this unit, you will be able to apply logic gates in digital system, define and create truth table using Boolean operators and or not, NAND, XOR, and logic diagrams. Understand SDLC stages, network topology, scalability, and need for cybersecurity with various encryption method. इस चीजों के बारे में हम कवर अप करेंगे। चैप्टर सेक्शंस 6 मेजर टॉपिक। इस चैप्टर में कितने मेजर टॉपिक्स हैं? नंबर 1.1 पे हम डिस्कस करेंगे डेटा रिप्रेजेंटेशन। 1.2 पे हम डिस्कस करेंगे एनालॉग एंड डिजिटल सिग्नल। 1.3 में हम डिस्कस करेंगे डिजिटल लॉजिक एंड गेट। 1.4 में हम डिस्कस करेंगे सॉफ्टवेयर डेवलपमेंट लाइफ साइकिल और 1.5 में हम डिस्कस करेंगे नेटवर्क टोपोलॉजी एंड नंबर 6 जो कि सेक्शन 1.6 है इसमें डिस्कस करेंगे हम साइबर सिक्योरिटी। तो सबसे पहले हम देखा व्हाट इज अ कंप्यूटर सिस्टम। अ कंप्यूटर सिस्टम क्या होता है? अ कंप्यूटर सिस्टम इज अ फंडामेंटल permeating part of modern life, revolutionizing how we work, communicate, learn. Number 2, not just a single device, it's a sophisticated combination of hardware and software working together. ये हार्डवेयर और सॉफ्टवेयर का कॉम्बिनेशंस हैं। पर्पस क्या इसका होता है? प्रोसेस इंफॉर्मेशन, सॉल्व प्रॉब्लम्स एंड एग्जीक्यूट टास्क, रिलायबिलिटी। हाउ अ कंप्यूटर वर्क्स एट दिस कोर, एवरीथिंग इज बाइनरी। इनपुट में क्या होता है? इनपुट को कैसे डिफाइन करते हैं? रॉ डेटा एंटर्स वाया कीबोर्ड्स, माउस, सेंसर्स, माइक्रोफोन्स एंड देन इनपुट टू प्रोसेसिंग में क्या यूज करते हैं हम? सीपीयू और एंड अरिथमेटिक लॉजिकल यूनिट परफॉर्म अरिथमेटिक एंड लॉजिकल कंट्रोल ऑपरेशन and then we are using the binary code, information stored as zeros and ones in memory, and then we will display the output. हम आउटपुट के लिए क्या डिस्प्ले का क्या यूज करते हैं? हम मॉनिटर यूज करते हैं और प्रिंटर। Results sent back to humans through screen and speakers. 1.1 section 1.1, that is data representation in digital computer. Two states, infinite power. A digital computer is made of millions of electronic switches. Each switch has only two states, that is on, binary 1, or off, that is binary 0. When current flows means on, it will be 1, and when no current flows, then it will be off, that is 0. A single binary digit, that is 0 or 1, is called a bit, the smallest unit of the data. From switch to code, the foundation of all computing. Off, binary 0 mean low voltage around 0 volt to 0.8 volt. Current does not flow, that is logic 0. And other one is on, that is binary 1. Binary 1 means high voltage around plus 2 volt to plus 5 volt. Current flows, that is logic 1. Used to represent true, yes, full, or presence. ASCII how computer stores characters. Alphanumeric codes. Codes that represent numbers, letters, and special characters are called alphanumeric codes. The most commonly used in ASCII, that is American Standard for Code for Information Interchange, use 7-bit or 8-bit per character, that is 128 possible characters in total. What can ASCII represent? ASCII can represent lowercase, that is A to Z. Example A का बाइनरी कोड होता है 65, स्मॉल लेटर में 97 होता है और कैपिटल लेटर में 65 होता है. और अपर केस A to Z, एग्जाम्पल A दिस 64 65 होगा. इसके बाद न्यूमेरिक डिजिट 0 to 9, एग्जाम्पल ये 5 का ASCII कोड है, ये 5 का बाइनरी कोड है. Next one is special characters like percentage, dollar sign and hash plus etc. एग्जाम्पल के तौर पर डॉलर साइन का ये बाइनरी कोड है. एनालॉग एंड डिजिटल सिग्नल्स. Analog signals, continuous, smooth, infinite values. Continuous signals that vary smoothly over time. Take any value within a range represented by a continuous waveform. Used in traditional audio, video transmission and physical phenomena. Example, audio cassette tapes, VHS videotapes, human speech, temperature readings, analog voltage signal. And then is digital signals. In digital signal, that is discrete, two-state binary values, that is 0 or 1. Discrete binary signals using a series of discrete values, typically represent as 0 and 1. 0 means absence, that is low volt. 1 means presence, that is high volt. Used in all modern electronic devices and communication system. Examples, binary code 0s and 1. Digital audio, that is MP3. Digital images like JPEG. Digital video MP4. Data in computers. Same data, very different representation here. How they compare across every important features. Feature, analog signals, digital signals. Feature is representation, analog signals, that is continuous waveform, while digital is discrete values, that is 0 and 1. Signal nature, infinite values within a range, limited discrete values. Noise, analog signals susceptible to noise, more resistance to noise. Transmission, in case of transmission, degrades over long distance with less degradation. Storage point of view, prone to quality loss when copied and reproduced without loss. इसमें कोई loss नहीं होता डिजिटल सिग्नल्स में. Scalability के लिहाज से not easily scalable. डिजिटल सिग्नल easily scale आप कर सकते हो. Complexity के point of view से often more complex, typical more straightforward. Examples, audio tape, temperature readings, digital audio, digital images. 1.3, that is digital logic and logic gate. The building blocks of every digital device. Digital logic is fundamental to electronic devices, calculators, computers, digital watches. Digital circuit consists of large number of logic gates working together. A logic gate is a building block performing a specific logic function. Each gate has 2 plus inputs, that is low means 0 or high means 1, and produce a single output in form of 0 or 1. The 7 common logic gates we will study. Number 1 is AND gate, and number 2 is OR gate. Number 3 is NOT gate. Number 4 is NAND gate. Number 5 is NOR gate. Number 6 is XOR gate. Number 7 is XNOR gate. AND gate. What is AND gate? AND gate means the rule is output is 1 means high only when all inputs are 1. अगर सब की सब input 1 होगी, then you will get 1. Mathematical expression means you will write f equal to x into y, x dot y. Description mean 2 input and f equal to xy. 3 input and f equal to xyz. Think all input must agree like and in English. Truth table xy and result is f. X is 0, y is 0, x is f will be get 0. X is 0, y is 1, result will be 0 because of AND. X is 1, y is 0, result will be 0. X is 1, y is 1, then result you will get 1 because both are inputs are 1. OR gate. In case of OR gate, if anyone output is high when any input is 1, अगर in एक भी input 1 होगी तो result क्या मिलेगा? High मिलेगा. Mathematical expression says f equal to x plus y. प्लस लगाएंगे जो कि OR गेट को शो करेगा. डिस्क्रिप्शन क्या है इसकी? नोट प्लस मीन्स OR ऑपरेशन, नॉट एडिशन. 3 inputs means OR f equal to x plus y plus z. Think at least one input is 1. This is the truth table. X, y and result will be f. X is 0, y is 0, result will be 0. X is 0, y is 1, result will be 1. X is 1, y is 0, result will be 1. X is 1, y is 1, result will be 1. Clear? NOT gate, that is inverter. You can say inverter gate. NOT gate, NOT means inverter gate. Rule is single input gate converts low to high and vice versa, and high to low. Mathematical expression f equal to x bar. X के ऊपर बार लगाते हैं या प्राइम कह देते हैं इसको. Description is also known as inverter. Bar in expression indicates inversion. Small circle in symbol equal to inversion. Okay, gate truth table is x and f. X is 0, f is 1. X is 1, f is 0. NAND gate. In case of NAND gate, rule is output is 0 only when all inputs are 1. Inverse of AND. Like f equal to xy और उसके ऊपर बार है. Description combines AND plus NOT gate. AND first, then invert result. Sometimes called a universal gate. Sometimes called a universal gate. Truth table हम लिखने जा रहे हैं. X, Y and F. X is 0, Y is 0, result will be 1. X is 0, Y is 1, result will be 1. X is 0, X is 1, Y is 0, result will be 1. X is 1, Y is 1, result will be 0. ये ट्रूथ टेबल है NAND गेट का. NOR गेट. NOR गेट में क्या होता है? रूल इसका ये है कि आउटपुट इज 1 व्हेन एनी इनपुट इज 1. इनवर्स ऑफ OR. ये OR का इनवर्स है. कोई भी इनपुट 1 होगी, आउटपुट इज 0 व्हेन एनी इनपुट इज 1. अगर कोई भी इनपुट 1 होगी तो रिजल्ट क्या आएगा? 0 आएगा. मैथमेटिकल एक्सप्रेशन में कैसे लिखते हैं हम इसको? f इक्वल टू एक्स प्लस वाई. पहले हम उसका प्लस करेंगे, फिर उसके ऊपर बार लगा देंगे. डिस्क्रिप्शन में combines OR plus NOT gate, or first then invert result, Output is 1 when only when all inputs are 0. सारी इनपुट 0 होगी तो रिजल्ट 1 मिलेगा. ट्रुथ टेबल लिखने जा रहे हैं हम. ट्रुथ टेबल में लिखेंगे x, y और f. x is 0, y is 0, result will be 1. X is 0, y is 1, result will be 0. X is 1, y is 0, result will be 0. X is 1, y is 1, result will be 0. तो ये ट्रुथ टेबल है नॉर गेट का. Next one is XOR, that is exclusive OR gate. Exclusive OR gate में हम क्या मैथमेटिकल रूल लगाएंगे, क्या रूल लगाएंगे इसमें? Output is 1 only when the two inputs are different. अगर दोनों इनपुट्स डिफरेंट होगी तो आपके पास आउटपुट क्या बनेगी? 1. मैथमेटिकल एक्सप्रेशन इज f इक्वल टू x, y के ऊपर बार प्लस x प्लस y. इसमें आपने x के ऊपर बार लगानी है. पहले ये x के ऊपर बार है, दूसरे में y के ऊपर बार है. ठीक है, इसको नहीं आपने लगाना. पहले x के ऊपर बार है, दूसरे में y के ऊपर बार है. Similar to OR, but adds curved input line. Output 1 when input differ, useful for comparisons. Often used in adders and parities checker. Truth table x, y, f. X equal to 0, y equal to 0, f will be 0. क्योंकि ये 1 कब देगा? जब आउटपुट क्या होगी? डिफरेंट होगी. x में 0, y में 1, डिफरेंट आउटपुट, रिजल्ट विल बी 1. x में 1, y में 0, डिफरेंट आउटपुट, रिजल्ट विल बी 1. x is 1, y is 1, same input, result will be 0. ये ट्रूथ टेबल है XOR का. Truth table understanding the concept. What is the truth table? Represents a Boolean function or digital logic circuit in table form. Table form में represent करते हैं इसको. Shows output responses to all possible combination of inputs. Logic 1 equal to true or high, or logic 0 for false and low. 5 key properties of a truth table. Number 1 is rows and columns. Made up of rows, input combination and columns, variables plus output. Number 2 is input-output map. Shows the relationship between inputs and outputs of a function or circuit. Number 3, all combinations. List every possible combination of input using 0 for low and 1 for high. Number 4 is binary counting. Input columns are constructed in binary counting order 0, 1, 2, 3. Binary counting भी आप लगा सकते हैं ट्रूथ टेबल में. पहले 0, फिर 1, फिर 2, फिर 3, फिर 4, 5, 6, so on. Number 5, output columns last. Means result of the Boolean expression appear in the rightmost column. Boolean identities, laws of Boolean algebra. What are the Boolean identities? Mathematical equation always true regardless of the variable values. Fundamental for simplifying and analyzing logical expression, essential for digital circuit design. Identity law, that is OR. ये क्या होता है? A plus 0 equal to 0. इसके बाद आता है identity law in case of AND. A dot 1 equal to A. Next, domination law, that is OR. A plus 1 equal to 1. Domination law, that is AND. A dot 0 equal to 0. Idempotent law, that is OR. A plus A equal to A. Idempotent law in case of AND. A dot A equal to A. Complement law, that is OR. In case of OR, A plus A bar equal to 1. And complement law in case of AND. A dot A bar equal to 0. Double negation means A of A means इसके ऊपर A है equal to A. Commutative law A plus B equal to B plus A. Associative law A plus C, A plus B plus C. You can write A plus bracket start B plus C bracket close. Distributive law A dot ब्रैकेट में आप B प्लस C लिख दे और इसको ओपन करेंगे A डॉट B प्लस A डॉट C के साथ. Absorption law A plus A into B equal to A. De Morgan's law A plus B prime equal to A prime dot B prime. De Morgan's law, that is second, A dot B prime equal to A prime plus B prime. Boolean function and their convergence to logic circuit. From expressions to circuit, a Boolean function uses binary variables plus logic operators and or not, parentheses and equal sign plus equal signs. Every binary values variable can take only 1 or 0, never anything else. इनमें सिर्फ दो ही वैल्यू होती है, 0 या 1. Any Boolean functions can be transformed into a logic circuit using AND or NOT gate. Example, converting f equal to x dot y to a circuit. Number 1, read the expression. F dot xy mean two variable x and y are and in together. Number 2, identify the gate. Dot operator means AND gate. We need 1, 2 input AND gate. Number 3, draw the circuit. Place in AND gate, connect x to input 1, y to input 2, output is f. Number 4, verify with the truth table. Make sure circuit output matches the expression for every input combination. What is K-map? K-map means Karnoff map, introduced by Maurice Karnoff in 1953. A simpler method for simplifying Boolean functions, reduce gate count and circuit complexity when converting expression to circuits. आप क्या कर सकते हो कि बड़े एक्सप्रेशन को के मैप के थ्रू सॉल्व करते हो और उसका रिजल्ट भी वही आ रहा होता है जो बड़े एक्सप्रेशन का आ रहा होता है. तो इससे के मैप से क्या होता है, हमारी कॉस्ट रिड्यूस हो जाती है और नंबर ऑफ गेट्स भी रिड्यूस हो जाती है. इट इज अ पिक्टोरियल फॉर्म ऑफ अ ट्रुथ टेबल, विजुअल एंड इनिशिएटिव. Why use a K-map? Because reduce complexity. Fewer gates needed when the Boolean expression is simplified. जब आप Boolean expression को simplified करते हो तो आपको थोड़े से गेट बाकी बचते हैं क्योंकि वो इसको सॉल्व कर देता है. Number 2, faster circuit. Simpler circuit with fewer components runs faster. Next one is lower cost. इससे lower cost आती है. Fewer components means less manufacturing cost in a real chip. And last one is visual simplification. Adjustment squares with ones form group, visual and initiative. Principle of duality in Boolean algebra. Duality means every identity has a twin. Duality state for any given Boolean expression, its dual is obtained by interchange and or plus operator. Replacing 0 with 1 and 1 with 0. 0 को 1 के साथ और 1 को 0 के साथ change करना. While keeping variables negations unchanged. Duality in action. Example, expression, its dual. 1 plus 0 equal to 1, 0.1 equal to 0, 1 plus 1 equal to 1, 0.0 equal to 0, a plus 0 equal to a dot 1 equal to a, and a plus 1 equal to 1, and a dot 0 equal to 0, a plus a equal to a, and a dot a equal to a plus a bar equal to 1, and a dot a bar equal to 0. Uses of logic gates real world application. Logic gates power the digital world. Logic gates are essential component in digital electronics and computing. They are used in many applications in various fields. मेमोरी सर्किट्स में यूज किए जाते हैं. नंबर 2 सिक्योरिटी सिस्टम में यूज किए जाते हैं. ऑटोमोटिव इलेक्ट्रॉनिक्स में यूज किए जाते हैं और कैलकुलेटर सर्किट्स में यूज किए जाते हैं. इसके अलावा होम ऑटोमेशन में, मेडिकल डिवाइसेस में और एरोस्पेस में और कम्युनिकेशन में ये तमाम की तमाम एप्लीकेशन है जहां पे लॉजिक गेट्स यूज किए जाते हैं. नेक्स्ट वन सॉफ्टवेयर डेवलपमेंट लाइफ साइकिल एसडीएलसी. SDLC means software development life cycle, process of creating new software system, and reinforcement enforces many software development techniques under one framework, provides a framework for planning and controlling the creation of software, describe the cycle of planning, writing, modifying, and maintaining software. 1.4.1 The 11 phases of SDLC. Number 1 is defining the problem. Number 2 planning. Number 3 feasibility study. Number 4 analysis. Number 5 requirement engineering. Number 6 design. Number 7 development, that is coding. Number 8 testing, that is verification. Number 9 deployment, that is implementation, and number 10 is documentation, and number 11 is maintenance or support. SDLC phases 1 to 6 plan, design, and specify. Defining the problem means clearly define the problem or system to be developed. All requirements are documented and approved before development begins. Number 2, planning phase. In planning phase means project plan is identified, team responsibilities, costs, resources, and accompanying budgets are documented. Number 3 is feasibility study. Assess technical, economical, operational, legal, and schedule feasibility before moving forward with development. Number 4 is analysis phase. In analysis phase, determine end user requirements and evaluate the need for system replacement or new development. Number 5, requirement engineering. In requirement engineering, identify and validate user expectation, functional and non-functional requirements documented in detail. Number 6, design phase. In design phase, create a architectural and user interface design, often using algorithm and flowcharts to specify the system structure. SDLC phases, that is 7 to 11, builds, test, deploy, and maintain. Number 7 is development and coding. Translate design into working software using programming language, database structure, and modules are created here. Number 8 is testing verification. All aspects of the system are tested. इसमें सिस्टम को टेस्ट किया जाता है कि सिस्टम अकॉर्डिंग टू द डिजायर रिक्वायरमेंट के मुताबिक काम कर रहा है या नहीं. अगर नहीं कर रहा है तो उसमें से एरर को रिमूव किया जाता है. Number 9, deployment implementation. Software is installed, activated, and personalized. Personnel trained. Old system is converted to the new system. Number 10 is documentation. Details documentations is an important part, creating manuals, architecture diagram, and code documentation. Number 11 is maintenance and support. Ongoing process, monitor performance, fix bugs, and new features. Integrate user feedback, the longest phase. Waterfall model versus sequential and linear model. Waterfall models, sequential linear development flows downward like a waterfall. Each phase must be completed before move to the next phase. Advantages means perfect for projects with clearly defined requirements. अगर आपके पास clearly defined requirements हैं, then you can use waterfall. Number 2, easy to manage, strict structure and milestones. Number 3 is each phase has clear deliverables and reviews. Documentation is comprehensive throughout. Best for small to medium sized projects. Disadvantages mean inflexible, hard to change requirements mid projects, long deliverable times, user wait until the end, high risk of failure if defects found late. Late detection of problem is very comprehensive to fix, not suited for complex or evolving projects. Agile model or iterative and flexible. The agile model, iterative and incremental short cycles called sprints. Team collaboratively plans, builds, reviews, and adopts in each sprint. Customer feedback drives priorities and adjustment throughout. Advantages: high flexibility and adaptability to change, continuous improvements through customer feedback, early delivery of working features like each sprint, and less risk issues caught early in iteration, better customer satisfaction and team collaboration. Disadvantages: number 1 is dependency on customer availability is a challenge. कस्टमर अवेलेबल नहीं होगा तो आप उसका फीडबैक नहीं ले सकेंगे. Potential for scope creep with the flexibility. Coordination challenges with larger team size, limited emphasis on long-term documentation, no ideal for projects with fixed cost and timeline. Network topology, how computers connect. What is network topology? Systematic arrangement of computers and devices in a network, the backbone of any networking application. Every network has one. Define how computers, servers, switches, routers, storages are connected. Good understanding is essential for building reliable network. 6 types of network topology. Number 1 is bus topology, all devices on a single cable. Number 2 is ring topology, devices connected in a circle. And number 3 is star topology, all devices connected to a central hub. Number 4 is mesh topology, every device connected to every other device. And number 5 is tree topology, hierarchical branching structure. Number 6 is hybrid topology, combination of 2 or more types. Bus topology, one cable that is means many devices. In bus topology, all devices share a single network cable. The bus data travels along the cable. Intended recipient picks it up, and each device connects via drop line, uses CSMA over CD protocol to manage shared access. Advantages: easy to install and maintain. Number 2, cost effective, require less cables. Number 3, good for small office networks, easy to add new devices. Disadvantages: if main cable fails, entire network fails. Network congestion, with many devices, slow speed when many users active, and difficult to troubleshooting cable issues. Star and ring topologies. स्टार टोपोलॉजी स्टार टोपोलॉजी में क्या होता है कि आपके पास एक सेंट्रल हब या स्विच होता है। तो आप क्या करते हो, सारी की सारी जितनी भी डिवाइसेस होती है वो सारी उस हब के साथ या स्विच के साथ अटैच कर देते हो। तो हब काम कर रही होती है एज ए मैनेजर, रिसीविंग सिग्नल्स एंड फॉरवर्डिंग देम टू द डेस्टिनेशन। ये सिग्नल रिसीव करती है और डेस्टिनेशन की तरफ फॉरवर्ड कर देती है। हब और स्विच में फर्क होता है, हब पैसिव होती है जबकि स्विच इंटेलिजेंट होता है। Advantages: number one, easy to install and manage it. Number two, if one cable breaks, other stay up. अगर एक भी केबल ब्रेक डाउन हो जाती है स्टार टोपोलॉजी में तो उसका कोई भी इफेक्ट नेटवर्क पे नहीं पड़ता। एक्सीलेंट फॉर परफॉर्मेंस, इसकी परफॉर्मेंस भी बहुत अच्छी होती है, चाहे वो ट्रैफिक ज्यादा हो या कम हो, इस पे कोई फर्क नहीं पड़ता। फॉल्ट इजीली आइसोलेटेड, आप इजीली इसका फॉल्ट भी ट्रेस कर लेते हो क्योंकि वही डिवाइस काम नहीं करेगी जिसपे कोई कोई प्रॉब्लम होगी। डिसएडवांटेज इसकी सिर्फ एक ही है कि फेलियर ऑफ सेंट्रल हब होल नेटवर्क डाउन। अगर हब और जो स्विच होता है अगर वो फेल हो जाए तो पूरे का पूरा नेटवर्क बैठ जाता है। और इसमें ये होता है कि मोर केबल रिक्वायर्ड देन बस की निस्बत ज्यादा केबल्स रिक्वायर्ड होती हैं। हब लिमिट्स नेटवर्क परफॉर्मेंस। Next is ring topology. In ring topology means devices connected in a closed loop. एक closed loop की फॉर्म में होती है, यानी कि ये बस होती है। अगर बस के स्टार्ट को और एंड वाले कंप्यूटर को आपस में अटैच कर दिया जाए तो आपके पास रिंग टोपोलॉजी बन जाती है। Each device has exactly two neighbors. हर डिवाइस के दो नेबर होती है, एक लेफ्ट साइड पे एक राइट साइड पे। डेटा ट्रेवल्स इन वन डायरेक्शन, डेटा एक ही डायरेक्शन में ट्रेवल करता है। पासिंग थ्रू ईच डिवाइस अंटिल रीचिंग द डेस्टिनेशन, डेटा क्या करता है कि हर डिवाइस में से होता होता हुआ कहां पहुंच जाता है जहां पे उसने पहुंचना हो, उस अपनी डेस्टिनेशन पे। यूज टोकन पासिंग प्रोटोकॉल। एडवांटेजेस इसके क्या है, इक्वल डेटा एक्सेस फॉर ऑल डिवाइसेस, हर डिवाइसेस के पास इक्वल एक्सेस होती है। नो सेंट्रल सर्वर नीडेड, इसमें कोई भी सेंट्रल सर्वर नहीं होता। प्रिडिक्टेबल परफॉर्मेंस अंडर लोड। डिसएडवांटेजेस, वन ब्रेक इक्वल टू इंटायर नेटवर्क डाउन, अगर एक भी केबल खराब होती है, किसी भी एक कंप्यूटर में फॉल्ट आ जाता है तो क्या हो जाएगा, इंटायर नेटवर्क डाउन। लिमिटेड स्केलेबिलिटी, एडिंग नोड्स डिस्टर्ब्ड, इसमें लिमिटेड स्केलेबिलिटी होती है और एडिंग नोड्स डिस्टर्ब होती है। स्लोअर देन स्टार फॉर मैनी यूजर्स, अगर यूजर ज्यादा हो जाएंगे तो क्या हो जाएगी, ये इसके स्टार से स्लो हो जाएगी। ट्रबल शूटिंग कैन बी कॉम्प्लेक्स, इसमें ट्रबल शूटिंग बहुत डिफिकल्ट हो जाती है क्योंकि किसी एक डिवाइस के खराब होने से पूरे का पूरा नेटवर्क बैठ जाता है और आपको नहीं पता है कि वो डिवाइस कौन सी खराब हुई है। तो आपको क्या करना पड़ता है, वन बाय वन सबको देखना पड़ता है, टेस्ट करना पड़ता है सबको, डिवाइस को, यानी कि एक डिवाइस को डी अटैच करेंगे, फिर देखेंगे नेटवर्क चलता है या नहीं चलता, फिर दूसरी को, तीसरी को, सो ऑन। मैश ट्री एंड हाइब्रिड टोपोलॉजीज। मैश टोपोलॉजी में क्या होता है, every device connects to every other device, multiple redundant paths exist for data providing exceptional reliability। मैश टोपोलॉजी में क्या होता है कि हर एक डिवाइस दूसरी डिवाइस के साथ डायरेक्ट लिंक भी होती है और इनडायरेक्ट भी होती है। एडवांटेजेस इसके क्या है कि हाईली रिलायबल, नो सिंगल पॉइंट ऑफ फेलियर, रिडंडेंट पाथ होते हैं इसके। इसके डिसएडवांटेज क्या है कि वेरी एक्सपेंसिव होती है, लॉट ऑफ केबल्स रिक्वायर्ड होती है, कॉम्प्लेक्स सेटअप होता है और हार्ड टू मेंटेन होता है ये। ठीक है, इसके बाद हम मूव करते हैं ट्री टोपोलॉजी में क्या होता है, हायरार्किकल स्ट्रक्चर होता है, लाइक इन inverted family tree combines characteristics of bus and star topology with the root node at the top, जिसमें बस टोपोलॉजी को और स्टार टोपोलॉजी को कंबाइन कर दिया जाता है एक रूट के साथ। एडवांटेज इसमें क्या होता है, इजीली स्केलेबल होती है, आप इजीली इसको एक्सटेंड कर सकते हो। सेंट्रल कंट्रोल होता है, गुड फॉर लार्ज नेटवर्क्स होते हैं, जितने भी बड़े नेटवर्क होते हैं वो इसको फॉलो करते हैं। और डिसएडवांटेज का ये होता है कि इफ रूट फेल्स नेटवर्क स्प्लिट मोर केबल्स देन स्टार, तो इसके लिए भी केबल्स ज्यादा रिक्वायर्ड होती है। इसके बाद हम मूव करते हैं हाइब्रिड टोपोलॉजी। इन हाइब्रिड टोपोलॉजी में क्या होता है, कंबाइंस टू और मोर डिफरेंट टोपोलॉजीज इनटू वन नेटवर्क। एक से ज्यादा टोपोलॉजीज को एक किसी भी नेटवर्क में इंप्लीमेंट करने को हाइब्रिड टोपोलॉजी कहते हैं। टेकिंग एडवांटेज ऑफ ईच ऑफन यूज्ड टू स्केल लार्ज नेटवर्क्स। एडवांटेज इसका ये होता है कि हाईली फ्लेक्सिबल होती है, रिलायबल होती है, स्केलेबल टू लार्ज एंटरप्राइजेस। डिसएडवांटेज डिसएडवांटेज इसका ये होता है कि कॉम्प्लेक्स डिजाइन एंड स्टार्टअप कॉस्टली रिक्वायर्स केयरफुल मैनेजमेंट होती है। ठीक है, ये इसके डिसएडवांटेजेस में आती चीजें। क्लाउड कंप्यूटिंग। क्लाउड कंप्यूटिंग क्या है, व्हाट इज क्लाउड कंप्यूटिंग? Provide access to combine over the internet, not local infrastructure. Dynamic, shared resources, server, storage, databases, networking, software, analytics. Access on demand from anywhere within the internet connection. Pay only for what you use, like electricity from the grid. Three services model, that is IaaS and PaaS, that is called PaaS and SaaS SaaS. आज में क्या होता है, IaaS में इंफ्रास्ट्रक्चर एज अ सर्विस। इसमें वर्चुअलाइज कंप्यूटिंग रिसोर्सेज होते हैं, सर्वर्स, स्टोरेज, नेटवर्क, यू मैनेज द OS and apps. Second one, PaaS, PaaS means platform as a service. A platform with tools to build, test, and deploy applications. You manage the apps and data. SaaS, software as a service, complete application delivered over the internet. You just use them. For example, Gmail, Office 365, Salesforce और Zoom, ये सब के सब SaaS की कैटेगरी में आते हैं। 1.5.4 Cloud Deployment Model. Cloud services can be deployed in three main ways, each with different ownership, access, and security. Number one is public cloud. Public cloud में क्या होता है? Resources owned by third party providers and made available to the public, और publicly के लिए वो available होते हैं। Example, AWS, Microsoft Azure Directory और Google Cloud. Best for startups, individual users, low cost needs. Second one is private cloud. Private cloud में क्या होता है? Exclusive to a single organization, better customization and control. Example, corporate data centers, banks. Best for banks, governments, regulated industries. Third one is hybrid cloud. In hybrid cloud, combination of both public and private clouds, flexible data and applications. Examples, e-commerce sites with sensitive payment data. Best for companies needing flexibility plus security. 1.6 is cybersecurity, protecting our digital world. What is cybersecurity? Practice of protecting computers, networks, devices, and data. Defense against theft, damage, malicious attack, unauthorized access. Also known as IT security or electronic information security, used by individuals plus businesses to keep data centers and systems safe. Why is cybersecurity important? Protecting sensitive data, personal information, financial data, intellectual property all needs protecting from theft and abuse. Preventing cyber attacks stops malware, ransomware, phishing, and DDoS before they damage your businesses or wallet. Safeguarding infrastructure mean power grids, transport, healthcare, critical system must keep running safely. Maintaining business continuity. Cyber attacks can halt business. Security keeps you running through threat. Compliance with regulations. Many industries are legally required to protect data. Non-compliance is costly. And preserving privacy means personal data must stay private. Security maintains user trust in digital services. Cyber security threat malware types. What is malware? Malware means malicious software, broad category designed to harm or exploit system. Common types damage in different ways covered below. Number one, viruses mean malicious code that attach to legitimate programs and spread when the infected program runs. Number two, worms, self-replicating malware that spreads across networks without user intervention. Trojan horse, software that appears legitimate but hidden malicious functions like remote control or data theft. Ransomware means encrypt your files or entire system and demands payment for the decryption key. Spyware collects user information secretly, often used for advertising or surveillance purposes. More cyber threats, phishing, DDoS, and insider attacks. Phishing, selecting engineers to mean social engineering attacks where cyber criminal impersonate trusted entities to deceive users into revealing sensitive information, login, credential, credit card, personal data, जिसमें वो कोशिश करता है कि आपसे ये सारी की सारी इंफॉर्मेशन छीनने की कोशिश करता है आपसे की क्रेडेंशियल्स को. Examples: spear phishing targets specific people, email phishing fake emails from banks or companies. Number two, DDoS attack mean denial of services attack aim to overwhelm a target system or network with excessive traffic, making it inaccessible to legitimate user. कि आपके नेटवर्क पे इतनी ज्यादा वो रिक्वेस्ट डाल देगा कि आपका नेटवर्क बैठ सकता है. इसको डीडोस अटैक कहते हैं. Examples: a single attacker floods the targets with traffic, often using multiple devices. Next is DDoS attack. Distributed DDoS. Multiple compromised devices coordinate to flood the target, making it much harder to defend against than a regular DOS. Examples: botnets, thousands of infected machines can be used to attack governments and large companies. Insider threats. Insider threats mean threats from individuals within an organization, employees, contractors, business partners who misuse their access for malicious purposes. Example: data breaches, financial losses, reputational damage, and very hard to detect. Protection against cyber threats. How to defend yourself. Protecting computer system against cyber attacks is crucial in today's digital age. Various methods and techniques are used together. नंबर वन इज स्ट्रॉन्ग पासवर्ड. आपको चाहिए कि आप स्ट्रॉन्ग पासवर्ड रखें जिसमें अल्फाबेट्स हो, स्मॉल लेटर्स हो, कैपिटल लेटर्स हो और स्पेशल सिंबल्स हो. एटलीस्ट 12 कैरेक्टर्स लॉन्ग आपका पासवर्ड होना चाहिए. बी वेरी ऑफ emails. Be cautious of unsolicited emails, especially those asking for personal information. Number three is educate yourself. Next is firewalls. You should install the firewalls. And antivirus software, install the antivirus software. And scan files and application for known malware, signatures, detects and remove threats. Encryptions, transform readable data into coded form. Only authorized user can read it. And then backup and recovery. You should take a regular backup. And when you will find any problem, then you can recover it easily. Last one is updated software. Try to update regularly. Encryption, the heart of digital security. What is encryption? Converts plain text data into an unreadable format called ciphertext. Uses algorithms and keys to perform the transformation. Protects sensitive information from unauthorized access. Even if intercepted, the data remains unreadable without the key. How encryption works: three key concepts. Number one is plain text. The original readable data you want to protect, like a normal text messages or documents. Number two is encryption algorithms, a mathematical formula or process that scrambles the plain text using a key, making it unreadable. And next one is encryption key, a secret piece of information used to control the encryptions and decryption process, the passwords to the algorithm. Two types of encryption: symmetric versus asymmetric. Symmetric encryption means uses one shared key for both encryption and decryption. Sender uses secret key to encrypt plain text. Receive uses the same secret key to decrypt ciphertext. Advantage is fast and efficient, simple to implement, strong security with strong keys. The disadvantage is key distribution is hard, limited to shared trust, and not for unknown parties. Other one is asymmetric encryption, uses two keys, public key and private key. Public key encrypt data, only the matching private key decrypts. The two keys are mathematically linked, but one cannot drive the others. Advantage is solve key distribution, non-repudiation, and ideal between strangers. Disadvantage is slower than symmetric, computationally intensive, and large key size is needed. Key vocabulary and concept. Master these definitions. They recur, recur throughout the unit and in the exam. Computer system, hardware plus software working together to process information. Binary code, information stored as 0 and 1's form. ASCII, standard code for information. American's standard code for information interchange, that is 7 to 8 bit represent characters. Logic gates and truth tables, Boolean algebra, K-map, SDLC, network topologies, cloud computing, cybersecurity, and encryption. Unit 1 key takeaways is summary, data representation and signals. Computer use binary, switches off 0 and 1, ASCII code letters, numbers and symbols in 7 to 8 bits. Analog signals, continuous signal, digital signal, discrete zeros and ones. Digital logic circuits, 7 common gates, and or not, NAND, NOR, X, or and XNOR. Truth table shows output for every input combination. K-map and Boolean identities used for simplify expressions. SDLC and network topology. SDLC has 11 phases from defining to maintenance. Waterfall equal to sequential plan. Agile equal to iterative sprints. Topologies are bus, ring, star, mesh tree, and hybrid. Clouds and cybersecurity. Cloud is IaaS, PaaS, SaaS means public, private, and hybrid. Threats, malware, phishing, DOS attack, ransomware, insider, encryption, symmetric versus asymmetric. Multiple choice questions, part number 1. Take your knowledge with these multiple choice questions from the textbook. Number 1, what are the two fundamental digits used in a binary code? Okay, the answer is 0 and 1. Number 2 is how many bits does the ASCII code use to represent the characters? 8-bit, 16-bit, 32, 4-bit. Answer is 8-bit. And in a digital computer, what do logic levels 0 and 1 represent in terms of voltage? Okay, voltage range is 0 and 1. Which of the following logic gates produces high output only when all its inputs are high? That is AND gate. Which principle in Boolean algebra involve interchange and or operators while negating the variables? That is principle of duality. Part 2 multiple choice question. Which phase of SDLC involve examining the existing system to identify its strength, weakness, and improvements? That is analysis phase. What is the primary purpose of a firewall in a network security? Monitor network traffic. Number 8. What is the main advantages of asymmetric encryption over symmetric encryption? Simpler key management, faster processing, lower computational complexity, higher data compression. Which model deploys cloud combining the advantages of both public and private cloud? That is called hybrid cloud. And what is the main advantages of mesh topology over the topologies? That is the redundancy and reliability. Short response questions. Practice these short answers exam question to consolidate your understanding. Number 1, what is principle of duality in Boolean algebra? Give example. Number 2, provide 2 example of devices using in digital signals and explain why. Question number 3, what is the primary purpose of the design phase in SDLC? What is the importance of the testing verification phase in SDLC? Why flexibility is essential in the development of a strong product? software product, sorry. Number 6, why does cybersecurity becomes important? Question number 7, why is bus topology suitable for small office networks? What is the role of CSMA over CD protocol in the bus topology? And why is mesh topology preferred for critical applications? And define cloud computing. Extended response questions, that is long questions, score 5 marks. You should prepare these questions. Design logic circuits for the following Boolean functions. Functions are given, you have to design logic circuits. Number 2, draw the truth table of the following functions. Number 3, simplify the Boolean function using K-map. Discuss the role of monitoring and updating during the maintenance phase of SDLC. What are the challenges? Outline the various methods of cloud deployment, including their advantages and disadvantages. How do organizations choose? Capture, store, and bring network topologies. Give their advantages and disadvantages. Explain symmetric and asymmetric encryption method in the context of cybersecurity. What is strong key important? Imagine you are tasked with the cybersecurity for large organization. Outline a comprehensive strategy that includes multiple layers of defense against threats. And last one is end of unit. Thank you. And if you have any question, you can write me in comment. We have studied, these are all the topics that we have studied here.